All right, so rinse and repeat 2.0. So we just got done looking at the example of having an odd number of ones. So here we're going to up the ante just a little bit. So we're going to be chatting about these bit strings that have an even number of zeros and at most one. So again, we can have an accept pile. So I've drawn them out already, so I don't have to come up with them on the fly and possibly mess up. So everything in that left side should have at most 1. They all actually have exactly 1. And we have an even number of zeros. So there's 2, 2, 2, no zeros, 4, and 4. On the reject side, we have a couple things that have too many ones, so 2 ones. We have one of them that has only 1, but an odd number of zeros. And then the last one is having no ones, but an odd number of zeros. So we have see why it's failing certain other categories. So the first thing I want to do here is I want to build a machine and then use that machine to maybe help me think through what the regular expression is going to look like. We can actually draw on some of the similarities from the previous one, this idea of jumping back and forth on these parity changes to actually see what's going to happen. So if I come in, I'm going to initially have an even number of zeros because I have no zeros at all. So that tells me I'm going to make that first state an accepting state. Then I can advance on the 0 and I could come back on the 0. So if I leave the left side, it's because I have an odd number of zeros. So I need to come back on a 0. So officially that little machine up on top is going to accept things that are only made out of zeros and have exactly an even number of them. So I could actually start drawing that out as a regular expression. So if I think through that, I'm going to have to always see 2 zeros, and they're essentially going to be coming in pairs. So I'm going to go across, come back, and I can do that as many or as few times as I'd ever want. So in regular expression land, that's going to look something like 0. That's not a marker at all. There we go. It's going to look like a 0, 0, star. So that's one component already, but that has not yet accounted for any ones at all. So now what I'm going to do is I'm going to begin trying to shove in some ones into this thing to try to see if I can improve this and kind of move things around a little bit. So if I have ones, I'm going to actually move this machine downward. So I'm going to say, okay, on a 1, I'm going to leave that first row. The first row has no ones. And I'm going to bring about a new row, which is going to have exactly 1, 1. Well, I'm allowed to have 1, 1. So I'm going to make an accepting state on the left shore and then make that rejecting state on the right shore. So I'm going to jump back and forth on my zeros. And that's actually all you need. That little machine is actually going to define the little language that we're actually looking at here. So the even number of zeros and at most 1, 1. If you wanted to, you could create the kind of garbage collector state that's going to say if you have any more ones, then you go off and die. But I don't need that if I want to draw this as a non-deterministic machine. What it does bring about, though, is it's going to bring about a couple other pathways into acceptance. So basically, we have this bottom left node, and we want to think about how we could get to it. Well, we have to go down at some point in time, and then we can jump back and forth. So let's think about going down on the left path first. So what it's going to happen here is that I could sit and dance around on the left, on the top as much as I'd want, as long as I end here. So what that means is I could jump around on zeros as long as I have an even number of them. So I'm sitting here. Then I'm going to come down on the 1. So it's going to force me to come down on the 1 path. And then I could officially jump back and forth on these zeros as much as I'd want to afterwards. So I can go to the right as long as I come back. So I'd have 0, 0, star. So maybe erase some of these things so you can kind of dwell on that a little bit. So you could jump around up here as long as you sit over on the left side at the end, then you come down. Well, if you leave, you have to come back. Leave, come back, leave, come back, leave, come back. So you could have as many double zeros after that as you would want. So in a regular expression, it looks very similar. The left and the right-hand side are going to have these double zero stars with a little 1 sandwiched between it. All right, so now let's think about how to come down on the right path. Well, what that means is I'm going to have to sit at this state before I come down. I sit at that state if I have an odd number of ones before the 0. So kind of like this example. I come across on a 0 and then I come down. So what I need to do is I need to think about drawing a regular expression that accommodates for having an odd number of zeros. Well, an odd number is just one more than an even. So you can hopefully start to see that this is going to look something like a 0, 0 star. And then I'm going to shove in another forced 0. So it's kind of like your Math 201 days of like, what does an odd number look like? Well, an odd number is one more than an even. So dance on the evens as long as you want, and then break out on the singleton 1. Then we're sitting here, so that singleton 0. Now I'm going to have to come down on the 1. Same exact thing is going to happen on the bottom part. I now need to have an odd number of zeros. So what I can do is I can force the single 1 to occur, and then I can dance back and forth on that thing as long as I come in pairs after that. So I can run this with a nice little 0, 0, 0, 0 star at the very end. So I effectively have kind of 3 nice little bins that I can begin living in. Basically, I can dance across the top row, I can come down on the left side, or I can come down on the right side. So I get these 3, whoa, created gigantic weird things. So let me erase those. Oh no, erased too much. When I go into highlight mode and then I go back and save it, it sometimes makes the highlight not transparent at all. So, all right, so here's the little pre-sketched out pictures with some of the nice color coding coming into play as well. So I have my 3 bins that I want to work with. What I'm going to see is that I can put all of these bins together and I could shove ors between all of them. And that's exactly how it is. So the regular expression is going to be literally the first thing, the second thing, or the third one. And we'll actually see a couple nice ways that we can begin shortening this thing up. And I'm actually going to bring that up once we jump into the implementation side of it. So I'm going to swap screens now for a second and turn my monitor off with the keyboard. I was bringing my keyboard across and I turned my monitor off. So we'll let that get fired back up. Good thing I have 3 of them, so I can easily move some of them around. All right, so share screen, swap back into what we would have seen last time. Now I'm going to delete those things all out and maybe add in some of the extra things that we were hoping to see before. So I'm going to delete this out. Maybe I'll leave the anchors there so I don't have to retype all of that stuff. So some of the ones that I was hoping to see accept would be like 0, 1, 0. We should see 0, 0, 1, 1, 0, 0, 1, 0, 0, 1, 0, 0, 0, 1, 0, 0, 0, and maybe just like a 0, 0 as well. And then things that should fail were what? Double 2 or double 1 obviously is going to fail. Anything that has 2 1s in it. Maybe I have an odd number of zeros with a 1, and then maybe just like an odd number of zeros. All right, so I kept everything else. So if you were creating a new document, I did switch to having the multi-line, which requires the anchors, and I'm going to keep the global thing on, and then we're going to create a little test bin of things. So the original version that I had here was going to then be the 0, 0 star followed by 0, 1, 0. So this is me coming down on the right side. So dance across the top, then come across the bottom and then move over to the left, and then 0, 0 star. So that's my initial one. You can start to see the things that actually are going to match that. So we have the 0, 1, 0 matches that, as well as that one. So that was one option. So now I'm going to do an OR. So shift underneath the delete key to get my vertical bar. Now we're going to have those ones that come down the left side. So things like 0, 0 star, the 1, and then 0, 0 star. So those are the things that came down the left side. So we have those things nicely highlighting. And then the thing we're missing is then just sitting up on top. So spinning on 0, 0. So we get this big old regular expression that then passes when we should pass and failed when we definitely should fail. All right, so that's kind of clunky. It's not great to work with, but it's not the worst. So I'm actually going to copy and paste and maybe just work down here, see a bunch of things that are clearly not going to be successful because they have parentheses and all that kind of stuff in. But if you stare at this long enough, you should realize that all 3 of these bins began and ended with 0, 0 star. So what I could do is I could essentially think about having the 0, 0 star as just one thing. And then I'm going to choose what happens in the middle. So the middle could be 0, 1, 0, or the middle could be a 1, or the middle could be nothing at all. So I'm going to delete that and showcase just that part. So we have 0, 0 star, so dance across the top, either come around on the right side, come around on the left side, or sit up on top and don't leave. So we have 0, 1, 0, or 1, or nothing at all. And then we're going to end with another 0, 0 star. So if I copy and paste that thing and put it up here, hopefully everything, whoa, don't do that. Copying and pasting is kind of crazy. All right, so if I copy and paste that, we should hopefully see all of the things blue that we did before, and we do. I'm not crazy about leaving the little blank thing in there. Obviously, it clearly works, but it's not ideal. What I like to do is I like to think about having this entire middle section as a thing that could exist, but it doesn't have to. So that actually has a very special little symbol, and it's actually over on our little cheat sheet. We have the A star, which is 0 or more. The A plus is 1 or more. And a question mark is 0 or 1 of the previous thing. So that allows me to have this wildcard. Do I want the middle or do I not want the middle? So it's very similar to the little epsilon transition that allows me to jump from one to the other without reading anything. So what I can do is I can basically view that entire middle thing as an optional thing. Either I can use the 0, 1, 0 or the 1, or I don't choose anything. So what I'm going to do is I'm going to delete that particular thing and then throw a big question mark around that. So that allows me to grab something from the middle, but I don't have to. So the not having to allows for the 0, 0. And that was the key one to make that one all work. Obviously, without the question mark, that all blows up and that thing won't work. But with the question mark, we allow to not have to take anything out of the middle bin. So as we go farther and farther down this thing, I'm going to slowly introduce some of these extra special little symbols so we can begin to have this nice war chest of all of our regular expression fun. So we'll kind of begin seeing all of the goodies come together and then begin blasting through a bunch of really crazy and cool things so that we are all good at writing regular expressions and not throwing out just garbage. So more about that as we go forward.